Okay, this video is for the fundamental theorem of algebra for Unit 1. There are some vocabulary words that you need to watch out for. Complex conjugate, imaginary root, repeated root, and to remember that a root is the same as solving the quadratic equation, is the same as finding the x-intercepts on the graph. So let's go through some examples of types of problems you'll see in this assignment. So first question is, how many roots does the equation have? So let's look at an example. 4x to the 5th minus 3x squared plus 9x plus 15 equals 0. So to find out how many roots a polynomial has, it has to deal with looking at the degree of the polynomial. Now remember, the degree of the polynomial is where we look at the biggest exponent there. So in this case, this is the highest exponent, and that's 5. So how many roots does this have? It would have 5 roots because it matches what the degree of the polynomial is. Another example, they might say solve for the roots. So again, just using that new vocabulary. So example, x to the 4th plus 5x squared minus 36 times 2x squared plus 9x minus 5 equals 0. So what we have to do is go ahead and see if we can factor each one of these, knowing that they are kind of in factored form already. We know that one of them is x to the 4th plus 5x squared minus 36 equals 0, and the other one is 2x squared plus 9x minus 5 equals 0. But in order to solve that, now we need to go ahead and continue to solve those quadratics. Okay, so to factor those, the first one will factor into x squared plus 9 times x squared minus 4. The other one factors to 2x minus 1 times x plus 5. And so now each one of these gets set equal to 0. So we have x squared plus 9 equals 0. Guess we don't need the parentheses anymore. And then we have x squared minus 4 equals 0. Down here, setting each one of those equal to 0 as well. And then we keep going. So looking at the x squared plus 9 equals 0, we solve this a couple different ways. So first we see that if I subtract the 9 from both sides, I get x squared equals negative 9. And then I would need to take the square root of both sides, and notice that I have a negative, so I get that complex root of plus or minus 3i. So there's 2 answers there. The next one was x squared minus 4 equals 0. I could do the same way where I add the 4 and take the square root, or I could know that that factors to x plus 2 times x minus 2. Either way will work, because then we have x plus 2 equals 0. If I subtract the 2, I get x equals negative 2. If I do x minus 2 equals 0, I add 2 to both sides and I get x equals 2. So there's 2 more answers. Last but not least, the other 2, we had 2x minus 1 equals 0. So we add 1 to both sides. We get 2x equals 1. divide by 2, so x equals 1/2. The other one was x plus 5 equals 0. Subtract 5 from both sides, we get x equals -5. So all of those answers are our roots. So we have -5, 1/2, 2, -2, 3i, and -3i. So how many is that? Well, there's 2, 4, 5, 6 answers. Now we might ask ourselves, how do we know that we had 6 answers? And when we go back here, this one shows that we had 4, but this one shows 2, but 4 plus 2, so 6 total roots that we were looking for, and we found them all. All right, another example, how many complex roots are there? So just wanting to know how many. So complex roots come from taking the square root of negative numbers. So we look for anywhere where we would end up with negative square root of negative numbers. So looking at this, here if I set it equal to 0, x equals 0, that's not complex. If I have x squared minus 4 equals 0, we saw this one, those gave us plus or minus 2, those are real. So our real focus is here, x squared plus 16. If I subtract 16, now I see that I will be taking the square root of a negative, and so therefore I will have 2 complex roots. Sometimes they want us to relate this to the graph. So for example, try to draw this as best as possible. Oops, that was supposed to touch. So this point right here, and this point right here. So they might give you the graph and then ask you how many real roots. So this is where we look at that vocabulary again, and know what roots mean again, and roots mean that they are the x-intercepts. So x-intercepts are here and here. So in this case we only have 2 real roots. Now the other thing that we realize is that this equation actually would have 2 roots that are the same, and it's because of this part here. But that's not all that important. But another question they might ask you is to complete the equation. So based on this graph, complete this equation. Y equals x minus blank, and then x plus blank quantity squared. So that's why the squared term is in there, because you actually get the same root twice. So we have to remember that if our root is -2 and 1, what did they look like in the factored form? So it would be x minus 1, x plus 2, because remember when we solve, that sign changes. All right, another example, find all roots of x to the 4th minus 9x cubed plus 28x squared minus 30x equals 0, given that 3 minus I is 1 root. So in this case, what we're really getting at is some vocabulary here. So if I know that 3 minus I is one of the roots, they come in conjugate pairs. So the conjugate to 3 minus I, its partner is 3 plus I. So conjugates mean that the sign in the middle is what's going to change. So how do I actually find the roots of this? I would need to do synthetic division to find this. So I'm going to do synthetic division for each of these into that equation. Okay. So 3 minus I is in the box, and then we need our coefficients of 1, -9, 28, -30, and of course we have to put a placeholder for anything that's missing. Alright, so synthetic division reminder, we bring down the first term, then we multiply it, but here we have an entire binomial, so we always have to distribute. So 1 times 3 minus I is 3 minus I. Now, we need to add these two numbers. So -9 plus 3 minus I, we just add like terms. So -9 plus 3 is a -6 minus I. Stays in there. Then we multiply again. So 3 minus I times -6 minus I. Again, you're going to have to FOIL that. So, remembering your foiling skills. So -6 times 3 is -18. -6 times -I is a +6I. -I times 3 is -3I. -I times a -I is a +I squared. But we know that I squared is -1. Now we combine like terms. We have -18 plus 3I minus 1. But now these two can combine, so we get -17 plus 3I. Alright, now we have to add. So 28 plus a -17 gives us 11 plus 3I. Then we multiply. So 3 minus I times 11 plus 3I. So 11 times 3 is 33. 11 times -I is -11I. 3I times 3 is +9I. 3I times -I is -3I squared. But again, I squared is -1. So we have 33. These two combine. We get -2I. But then we have a -3 times a -1 gives us a +3. And so now these two can combine. And we get 36 minus 2I. Then we add. So -30 plus 36 is 6 minus 2I. And we have to multiply again. FOIL, 3 minus I times 6 minus 2I. So 6 times 3 is 18. Minus 6I minus 6I. Now, what is... Should it have been... Okay, I realize my error in going too fast. The error I have here, unfortunately, is right here. So that should be negative 19. Just going too fast. That's what happens. So 28 minus the 19 is 9. So this is a 9. But then we have to multiply that and fix it. And so fixing that, this part is 30 when I multiply those. So then when I add those, I get 0, and anything times 0 is 0, so it comes out 0. Now, here's our new polynomial. So remember, that's our remainder, and then the 0 is our constant. So we have x cubed plus negative 6 minus ix squared plus 9 plus 3ix. Sounds really weird, but now we need to take this polynomial and its coefficients and do synthetic division with this this one's conjugate pair. Okay, so let's do that synthetic division. So now we're going to use the 3 plus I to go in the box. And now our coefficients are 1, negative 6 minus I, 9 plus 3I, and 0. And so we bring down the first number, multiply, we get 3 plus I, and then we add. So negative 6 plus 3 is a negative 3, negative I plus I is 0. Now we multiply, so negative 3 times 3 plus I. So that's a distributive rule. So negative 3 times 3 is a negative 9. Negative 3 times I is a negative 3I. But now we add. So 9 plus a negative 9 is 0. 3I plus a negative 3I is 0. And then we multiply. Well, anything times 0 is 0. Add, we get 0. So this is our remainder again. So we're left with x squared minus 3x. Okay? Now, what's cool about this is notice we have broken down our polynomial into something that is very doable to just factor it the way that it sits. So x squared minus 3x, and when we set that equal to 0, then we know we can pull an x out of there, and we're left with x minus 3. Set each one equal to 0. X equals 0, x minus 3 equals 0. Add 3 to both sides, x equals 3. So it says list all of the roots. So our roots are 3 minus I, 3 plus I. Then we found that we also have 0 and 3 as our answers. And our original polynomial, going back, is x to the 4th. So I should have 4 roots, and we ended up with 4 answers, so we are good there. Clear these out for the next example. Alright, what is the least possible degree of a polynomial that has these roots? So least possible degree. If our polynomial has the roots of negative 5, 1 plus 4i, and negative 4i. So remember what the definition was for roots. We said if we ever have complex roots, they have a conjugate partner. So 1 plus 4i also has 1 minus 4i, and negative 4i has a positive 4i. So now what I need to realize is that the degree of the polynomial matches how many roots we have. So we have 1, 2, 3, 4, 5. So the degree of the polynomial needs to be 5. Last example, write a polynomial equation. Of degree 4 that has the following roots. And so then they're going to give us what roots we have. So -1 repeated 3 times, and 4. So those are all our roots. We don't have to worry about any complex ones because we want a degree of 4. And if I have -1 repeated 3 times, that's -1, -1, -1, and 4. So to write an equation, remember we put these back in factored form, so the sign goes back the other way. So x plus 1, x plus 1, x plus 1, and x minus 4. Now, in this case, if asked, then I could FOIL all of those and get the polynomial, which is the easy part. So I would just multiply all those together, a bunch of FOILs, and get the, combine like terms, and I would have the equation. So that's the end of this class live. Now you'll need to call, text, or Skype message me so you can answer a couple questions and get credit for this recording. Have a great day.